Hello everyone and welcome. Have you ever come across the Greek letter gamma in a thermodynamics problem and wondered what it is? Today, we are going to demystify this important value. We will learn what gamma represents and, most importantly, how to calculate it in a few simple steps. So, what exactly is gamma? In thermodynamics, gamma is known as the heat capacity ratio or the adiabatic index. It's a simple ratio of two other important properties, the specific heat at constant pressure, called Cp, and the specific heat at constant volume, called Cv. The formula is just that, gamma equals Cp divided by Cv. This number is crucial because it tells us how a gas behaves when its pressure and volume change without any heat being added or removed, a process called an adiabatic process. Think of the rapid compression of air in a diesel engine or the way sound travels through the air. To calculate gamma, you first need to find the values for Cp and Cv. There are two main ways to do this. The first method is for ideal gases and uses something called degrees of freedom. Degrees of freedom refer to the number of ways a molecule can store energy. For a simple monatomic gas like helium or argon, which is like a tiny single ball, it has 3 degrees of freedom. For these gases, Cv is equal to 3/2 times R and Cp is 5/2 times R, where R is the ideal gas constant. When you calculate the ratio Cp/Cv, the R cancels out, leaving you with 5 divided by 3, which is about 1.67. For diatomic gases like oxygen or nitrogen at room temperature, they have 5 degrees of freedom. So, their Cv is 5/2 R and their Cp is 7/2 R. This gives a gamma of 7 divided by 5, which is exactly 1.4. This is a very common value you'll see for air. The second, and often more practical method, is to simply look up the values. For real-world engineering and science, you would use a thermodynamics table. These tables provide precise values of Cp and Cv for many different substances at various temperatures and pressures. You just find your gas, find the conditions, get the two values, and divide them. It's the most accurate way to find gamma for real gases. So, to recap, gamma is Cp divided by Cv. You can estimate it with degrees of freedom for ideal gases or find it precisely from data tables. Thank you so much for watching. I hope this explanation made calculating gamma a little bit clearer for you. If you found this video helpful, please give it a thumbs up and consider subscribing to support the channel. Your support allows us to keep making more educational content just like this. Let me know in the comments if you have any questions, and I'll see you in the next video.